So in this lesson, we are going to be solving equations with variables on both sides. All right, so for this first example, let's just consider that we have a square. Some things we know about the square is that all of the sides are the same length. Okay, so let's say I used an algebraic expression to represent the length of one of the sides. For instance, let's say this one equals 3x plus 8. All right, and let's say the other side is represented by 5x minus 2. All right, well, if we know that these side lengths are the same, then we know that this expression is equal to this expression. Both of those are equal to each other. So we can set up an equation. We could say that 5x minus 2 is equal to 3x plus 8. All right. So at this point, we have, again, an equation to solve. But you'll notice you'll have a variable on both sides. So we have 5x here, and we have 3x on this side. We also have constants on both sides. We have a negative 2 here, or we're subtracting 2 on the left side, and we're adding 8 on the right side. So what we have to do is get our variables on one side and our constants on the other side before we can solve. So the first way I'm going to show you how to solve this is to use opposite operations. Let's go ahead and start with the variables. So let's say, actually, you know what? Let's start with the constants. So if I want to get my variables, my x's on the left side and my constants on the right, I need to move this minus 2 from the left side. All right, so the opposite of subtracting 2 is to add 2. So let's go ahead and add 2 to the left side. Now, we're not adding 2 to the 5x. We're just adding 2 to the negative 2, so those will cancel. And remember, we can do that as long as we add 2 to the other side as well. And again, I'm not adding 2 to anything but the 8. I'm not adding 2 to 3x. It's just the constants that we're dealing with, okay? Now, I think you remember that these 2's cancel each other out, because negative 2 plus 2 is 0. So on the left side, all we have left is 5x equals. Okay, well now we still have this 3x on the right side. So we're going to go ahead and write our 3x. Okay, and then we have this plus 8 and plus 2. Well, 8 plus 2 is 10. It's positive 10, so I'm going to put plus 10. Now, I'm closer because I've got my constants together. I only have this one positive 10 or plus 10 on the right side. But now I've got to get my x's together. So again, I'm going to move my variable to the left side. I'm going to get them together on the left side. Well, I've got to remove this 3x. What's the opposite of, and this is a positive 3x. There's not a sign in front of it, so it's just a positive 3x. And I need to, the opposite of positive is subtract. So we're going to subtract 3x because 3x minus 3x is 0x. We'll have no x's, no variables on the right side. But again, we have to do the same thing to both sides. So I'm going to subtract 3x from the left side. Now it says 5x minus 3x. Well, 5x minus 3x is 2x. And on the right side, remember this canceled, so all we're left with is 10. Now we have to solve. We're trying to solve for x. It's being multiplied by 2. So we're going to do the inverse, or the opposite operation of multiply by 2 is to divide by 2. 2 divided by 2 is 1. So on the left side, we just have x equals, and then when we do 10 divided by 2, we get 5. So x equals 5, and that's our final answer. Now for this example, I'm actually going to use the exact same equation. I want to show you a kind of a different way to solve it, all right? Now, don't let this way confuse you. I just want to kind of give you an additional resource if you need it in terms of solving. Remember in class, I talk about considering these as separate terms. So we have a 5x, and we have a -2, and we have a 3x, and we have a +8, okay? Well, if we want to get these together on the same side, anytime you move a term to the other side, you just change the sign of it. If it was, for instance, if -2 is on the left and we move it to the right, it becomes +2. If we have a 3x on the right side and we move it over to the other side, it becomes -3x. So it doesn't matter which term you're talking about. As long as you move a term on to the different or to the other side of the equation, you just change the sign. So for instance, in this example that we just did, okay, instead of adding and subtracting from both sides and solving equations that way, which is really a good way and the best way probably to work them out, I'm just going to show you how to move these terms. And this is a strategy. If you want to use it, you can. Okay, so I'm going to get my x's together on the left side. Well, I already have a 5x. Okay, but now I want to take this 3x and move it over. Well, if it's a +3 and it comes over here to this side, it becomes -3x. All right, now I'm going to put my equal sign because that's all I want on this side, or on the left side. Now I'm going to get my constants together on the right side. Well, I already have an 8. So I could go ahead and write down my 8, but then I'm going to take the -2 and move it over, and it becomes +2. Now what I've done is I've put my like terms together. I've put my 5x and -3x on the left side of my 8 + 2, and I can simply just combine those like terms. So on the left side, 5x - 3x is 2x. And on the right side, 8 + 2 is 10. And that's that same equation we were working. In order to solve this, we divide by 2. And when we do that, x equals 5. So that's just another way of setting up the equation and working through to solve it.